Another thing we will now take a look at is how to troubleshoot FTD, how to do some basic troubleshooting. This session is going to be especially useful when you experience some problems related to the data plane and you want to see where the problem actually occurs, because there are going to be two places where you might see issues with FTD. Remember that this is a combination of two different codes, the ASA and Firepower. We have two different engines, or just a set of engines. We have the Firewall ASA Lina operating system, which is what makes our data plane, and we have the Firepower engines, like for example access control policy, security intelligence, SSL decryption, and so on. Now, there is actually a pretty good document that explains this difference. If we go to the documentation and look for, we should be able to find it under Firepower Next Generation Firewall Troubleshooting Tech Notes. It's a pretty recent document. Work with Firepower Threat Defense Captures and Packet Tracer, because this is what I want to focus on in this session, these two tools. So at a very high level, as you can see here, as the packet is entering the FTD device, it is actually processed by the ASA, by the Lina data plane. It is then possibly sent to the Firepower engine for inspection, and then as it goes back, it is sent out of the data plane interface, which is part of the ASA's OS. And as we will see in just a moment, taking this information into account is going to be critical when you plan to look at packets dropped on the FTD. Okay, so in terms of the troubleshooting tools, it is going to be stuff like connection events. You can take a look at analysis, connections, events. It is going to give you an overview of the sessions. And this is something that we will be extensively using throughout the other videos. At this point, our device is not configured with data plane interfaces, so there is no communication going via the FTD. We will not see anything here. Okay, the other tool, or just tools, this is for basic connectivity. We already took a look at some of these. So a bunch of show commands, ping, traceroute, pretty basic stuff. All of these you can access from the CLI, and some of them you can access via the GUI, depending on the FTD's version. But now the two most important tools they want to take a look at in this session, this is going to be Packet Tracer, and it is going to be Packet Capture. Now, Packet Tracer is something that you hopefully have experience with. Now, this is how we can emulate a flow, or just to emulate a set of packets that are to be processed by the FTD engines. So it's like when you specify the source destination, port numbers, you tell it where the packet enters, on which interface, and you want to see how the packet is going to be processed by FTD by its different engines. Very useful stuff. This is taken directly from the ASA's code. But in terms of packet captures, this stuff can be actually enabled at two different places on FTD. We go back to this document and take a look at this drawing here. This is a pretty detailed description of how the communication is processed as it enters on the physical or logical interface associated with the data plane, and then it is processed by regular Lina features like network address translations, like basic layer 3.4 filtering, and then it is processed by the Firepower engine features to finally get back to the data plane, be processed by a few other engines like VPNs, translations, and to finally leave the physical port out to the network. Okay, so the key thing here is that there is going to be a difference, and not only in the syntax for the capture commands, but more importantly in the actual places where those captures will be activated. If we go for the old style capture command, this is something that we will activate right after the packet enters for the FTD's interface. So right after we get a packet from the network. But when you say capture dash traffic, it means that you want to run a capture after the firepower, all firepower processing was done. So this stuff is the firepower engine over here. So logically, it's after DAUQ, which stands for data acquisition. It's over here, and when you issue this second capture. And of course, the reason that this is important is that in some cases, you might see a packet collected over here as it enters the appliance, but you will not see it using this second capture. This is immediately telling you that the packet was received, it made it through to the FTD, it was something on the FTD that caused the packet to be dropped. Okay, and capture, like on the ASA, you can also enable it on the outgoing interface. So as the packet enters the network or leaves the network. Okay, so with these three places, if you take this information into account, you will be able to pretty much tell what was the component or just one of the two main engines of the ASA what caused the packet to be dropped. Like when I see a packet over here and over here, but it's not showing up over here, it is immediately telling me that it was something from this portion of the ASA engine what dropped the packet. Just to quickly recap on the syntax, in case of the firewall engine, the ASA Lena operating system, this is going to be the syntax. It's the same like on the regular ASA. You will say capture, specify interface, maybe match certain traffic, possibly use an access list, and you will take a look at it with show capture command. You can also download this information via HTTPS from FMC. And for this to work here, we'll just have to enable the web server and then use this URL to get to the file. So just a quick example to recap on the full syntax. Like if I want to look at the ICMP communication between the two hosts, this is how I would build my capture statement. Okay, then for the firepower engine, it is going to be the capture dash traffic command what we will use. And we have several options. Like, do we want to see Ethernet headers, maybe print ASCII values, specify a number of packets we want to capture. Plus, there is also going to be some keywords that we will use to narrow down the scope of the communication that we want to look at. So this syntax is more of like regular TCP dump, a Linux tool, where you use the different arguments to tell it what's the source, what's the destination, and what are the port numbers you want to look at directly for the capture traffic command. You can also use the Boolean logic to add conditions to the capture statement. Just a few examples to show you a full syntax. Assuming that we want to look at communication, web communication between a web server and a host in both directions. So from the host to the server and then from the server to the host. You could use this syntax. I want to capture 5 packets. And I don't really care about the source and destination. I want to look at this single IP address and this single port number. So if this information is in the flow, I'm going to capture it. Versus if I only want to look at SSH communication originated by a client 10111, I'm going to say that it's the source what's 10111, and I will tell it that port 22 is my destination. Now, in the newer releases of FMC, you will be able to use these two tools directly from the GUI. Maybe let's quickly look at this. Devices, device management. FTD is already registered, so we should see an entry here. Okay, when it gets the data, take a look at this wrench and screwdriver icon. This is how you can access some of the troubleshooting tools on this particular FTD. So in this case, the goal here is obviously to take a look at the data plane from the sensor's perspective. We don't really care about capture on the FMC. Okay, now we have to go to advanced troubleshooting. And since I am running 6.2, we will see not only the ping, not the ping, the CLI syntax, or ping show trace route, but we can also use packet tracer or a capture with trace. And this is essentially a combination of packet tracer and capture. For the packets that you capture, you will also immediately see a packet tracer like information when you use this tool.